Okay, here's part 3 of this June 2023 Physics IGCSE Edexcel paper. Part 1 we went through questions 1 to 3, part 2 went through questions 4 and 5. So if you want to go and watch those first, go and have a look. Like, share and subscribe as usual. I do them for free. My payment is that I get lots of likes to help with YouTube because otherwise people don't get to see the videos. That's the currency in YouTube, so it needs lots of likes, needs your help, and make sure you're subscribed if you want to know when the next videos are uploaded. Okay, so this question covers both waves and density. That's a strange combination, but let's see how it combines them. The photograph shows an X-ray image of a person's knee. The person has had part of the knee replaced. Okay, part of their knee replaced, which will be these whiter areas here. It's the knee replacement surgery. Okay, and they put, I think it's a titanium that they use on the knee that perhaps has worn out too much. Okay, so it says X-rays, part A says X-rays are part of the electromagnetic spectrum. So giving you information. All electromagnetic waves are transverse waves and transfer energy. Okay, so those of you who remember question 1, yeah, electromagnetic waves are transverse. Yeah, now all waves tend to transfer energy, so they're just giving you some information about waves. State another property that all electromagnetic waves have in common, yeah, other than the fact that they are transverse and transfer energy. Yeah, what's another piece of information that all electromagnetic waves have in common? Well, they can all travel through space or vacuum at the same speed. Yeah, in a vacuum they all travel at the speed of light, what we call the speed of light, which is 3.00 times 10 to the 8 meters per second. In GCSE they tend to use 2 significant figures. In A-level, it's 3. If you go to more than 3 significant figures, it's 2.999 something, or it starts getting slightly below 3. Okay, so it says state a harmful effect of excessive exposure to X-rays. Okay, excessive means too much. So in excess, for those of you studying or those of you whose English is not their first language. So excessive exposure of highly ionizing radiation, yeah, this is basically what they're saying, it can lead to cell mutation or cell damage or a risk of cancer. These are 3 clearly explained terms. Don't just put mutation. Make sure you're not leaving anything to the imagination of the examiner. If they can find a reason to lose your mark, then this could be a risk that you take by not being clear in your answers. Part 3 says A, part 3 now. It says describe the difference between transverse and longitudinal waves. So they both can transfer energy. So if energy transfer is to the right for both of them, I've drawn them as a diagram. But the diagram is not going to get you marks unless you can describe the difference between them. Okay, so what's the difference? Well, transverse waves vibrate up and down if the energy transfer is going to the right. So the vibrations or oscillations are at right angles or perpendicular to, so you get a mark for perpendicular to, the direction of energy transfer or wave travel. So that's the level of detail you've got to put in. So the diagram is just helping you, right? Whereas when you're doing longitudinal waves, make sure you draw them as parallel lines. Don't draw them as a squiggly line, because then it looks a bit like the transverse wave. So I draw them as parallel lines, and there's areas of compression here, areas where the layers of the medium get squashed together because they're basically pressure waves. Yeah, so sound wave is a typical example. And the distance between the areas of high pressure is the wavelength. And again, the oscillations this time would be to and fro, or left and right if the energy transfer is to the right. Okay? So I've drawn the energy transfer in the diagram to the right, and the oscillations are parallel to, this time, the direction of wave travel or the direction of energy transfer. Okay? So this is how you describe the differences. And this is a common exam question. So once you've learnt it clearly and in detail, you will be guaranteed these marks if it comes up in your exam in the summer. Okay? So that's the waves section. Remember, it was about a knee as well, X-ray. It then says a diagram shows the part of the knee called the patella. Yeah? The patella is basically the kneecap. The patella has been removed from a person's knee. Oh dear. I don't think, maybe they want to replace it with a titanium knee. Who knows? I don't really know enough about it. So they've removed the patella, and this is the shape of it. It's a small, irregularly shaped bone. And the key word is irregularly shaped, because they want you to do something to do with density. And it's denser than water, so it's not going to float. So again, they're giving you information that they should trigger a thought, this information. Describe how to find the mass and the volume of the patella. Okay? Obviously, you should do it as accurately as possible because it's another method. But they're not asking you to determine the density. They want you to tell them how to measure the mass and the volume. Now, the reason they're telling you it's denser than water is because you can use a displacement can to collect the water that it displaces. Remember the displacement can. Now, for those of you in my class, we did this experiment, and if you're focused and you made your notes as requested, it should be an easy 4 marks. Now, remember, the theory is density is mass over volume, but they don't want the theory. They want you to tell them how to measure the mass and the volume. Well, for the mass, you need a mass balance. Yeah, so that's the apparatus first. For the volume, you need a displacement can, and at least you need a measuring cylinder. Yeah? So obviously, if you know that, then you can write out your method in a clear, concise, bullet-pointed way. So you can say, to measure the mass, we need mass balance. To measure the volume, I would use a displacement can and a measuring cylinder. And you probably need a beaker as well, because you wouldn't necessarily put the displacement can above the measuring cylinder. I've drawn a diagram to show you, to remind you of the equipment. Yeah? So the displacement can is drawn. You lower the patella into the water. You fill the water up to the spout. This bit is called the spout. For those of you who struggle with your English, you then, when you fully submerge the patella, so the patella goes in the water gently, so you don't get any splashes, so you move it in there, the water will be collected in a beaker. Yeah, you then pour the water into the measuring cylinder, and you get to eye level to measure the meniscus, the bottom of the meniscus. Remember the meniscus? It curves up the side of the walls due to the attraction between water and the material of the measuring cylinder. So you've got to have a method for your mass and a method for collecting the water displaced to measure the volume, and you measure the volume this way. So you do need a measuring cylinder. And then, obviously, further detail will give you more marks, and here's some accuracy points I've listed for you. So all of these points will help you with accuracy. Okay? Totally submerge. Fill the displacement can up to the spout. Remember, the spout is the bit where the water comes out. No splash, try to avoid splashing, so you lower gently, read the volume at eye level, and remember the meniscus, yeah? Eye level and the meniscus is a key point for doing these questions. You could also check that there's no zero error on your balance. Make sure it's on zero. Make sure you're measuring the bone, the patella, when it's dry, not when it's wet. And make sure the balance is on a flat surface so it has no errors on it. Okay, and then you can look at the mark scheme. So let's see if the mark scheme is here. I think it was before. Way before. Let's see. All right, so 6A was about the waves. So you can stop the video, have a look at your own answers, see the notes that they put in for the 6A part 1, 2, and 3. Part B is the method that we're just going through. Yeah, and they're giving you all the notes. They're giving you basically 1 mark for the correct pieces of equipment, for mass and for volume. So you've got to have included both to get that mark. Then using the displacement can method will get you 1 mark. Yeah. And the 3rd mark would be for further detail of your method. So someone who puts more detail in will get the 3rd mark, and someone who just puts a very general answer may only get 2. Yeah. So further detail of the displacement method, because obviously this one is a bit more explanation required than the mass. Mass, you just put it on the balance. And then for accuracy, these are the points that I mentioned to you. So you get 4th mark is for paying attention to and describing how you'll make it accurate. Okay? Hope that makes sense. So this is a common practical. You need to know, and each time they'll give you a slightly different scenario, and you've got to be able to deal with it. Okay, so we did 6A, and the method. The question then finishes off nice and easily with determining mathematically the density of the patella. They give you the information that you require. Yeah, and again, look at what the units they want. They want grams and centimeters cubed, which in a lab, secondary school, is easier. The values they're given you to 2 significant figures. So your answer should be to 2 significant figures. Put the numbers in, use the correct equation. That's 2 marks already. If you did 3 significant figures, it'll be 1.31. And if you forget to put it to 2 significant figures this time, you will lose the mark because they're telling you to put it to 2 significant figures. Okay? Be careful. So that's the 13 mark questions. It's the longest question so far for this paper. And there is the mark scheme for part C. So you can pause the video and take a look, mark your own paper and see how well you did. Do corrections. And question 7 then is about electricity. It's 9 markers, so we'll do 2 questions in this video. Question 7 is about electricity. The circuit diagram shows a motor symbol with a circle and M in it. Yeah. A power supply, which is a DC power supply because it's got positive and negative on it. A switch and a variable resistor. Yeah. So that's the variable resistor symbol. You do need to know your circuit symbols. The switch is open and the motor is not moving. Obviously, if the switch is open, that means there's no complete circuit. There'll be no energy. State how much energy is in the kinetic energy of the motor. The motor is not moving, so none. Yes? The answer is 0. A lot of students got that one right. Okay, the switch is then closed and the current will flow. The motor takes 0.42 seconds to reach its maximum speed of rotation. So they're telling you that it takes 0.42 seconds to reach its maximum speed of rotation. The average current, or the mean current, is given, and the voltage across the motor was about 7.1 volts. Again, to 2 significant figures. They're giving you the voltage, the current, and the time. They want you to show that when you work out the work done by the motor, now work done by the motor is called electrical energy transfer. So work done by electricity is not force times distance, for those of you who got confused by the term work done. Electrical work is work done, not force times distance, but it's voltage times current times time. So you put the three values in, and if you do it to three significant figures, you get 11.6, which is about 12 joules, and that's how you show it. Show it means prove it mathematically, which means to two significant figures show that the value you'll get when you put the three numbers together is closest to 12 joules, okay, which is what we have shown. All right, so that's part A and B done. Part C then shows what's called a Sankey diagram. So Sankey diagrams are these arrows, and the width of the arrow shows how much each portion of the energy transfer is equal to. So if it's drawn to scale, the width of the arrow here, represents the 12 volts, 12 joules, which is transferred to the motor electrically. Electrical work is done, remember, that's what you just worked out, from the battery. So the energy transfer is an electrical energy transfer from the motor to the motor from the battery. So technically it's chemical energy going in, and then coming out is kinetic energy. Now you can see over here it's not the full width that's come from the beginning of the arrow, because some of the energy is wasted or lost to the surroundings, and normally the wasted energy is thermal energy, so it's gone to the energy store in the surroundings, so it's dissipating as heat and spreading out. Dissipating means given out and going into the molecules of whatever is around, so normally air. So you can see the arrow for thermal energy is much narrower because it's representing 2 joules, and for the kinetic energy, the useful output is 10 joules. Normally the useful output is shown going forwards, and the wasted or lost energy from the system is shown as going downwards. But sometimes there's more than 2 bits to it. Okay, so that's what a Sankey diagram shows. It basically shows you the efficiency, diagrammatically, of the energy transfer. So use the Sankey diagram, it says, to calculate the efficiency. Well, the efficiency is the useful output divided by the energy input. Well, the energy input was from the battery, so there's the energy input, 12 joules, and the useful output was the kinetic energy, that's what you wanted. So that's 10 joules, so you divide 10 by 12, and you should multiply it by 100, although you don't have to, but in this case, if you see down here, they want the answer as a percentage. So the efficiency normally could be given as just 0.83, or 83% if you make it into a percentage. And you should put it as a percentage, otherwise you'll lose the third mark. Okay? And it says it will allow you to put 0.83 if you physically remove the percentage sign, here. Okay, so you have to remove it to show you that you know that you've changed it from percentage to decimal. Okay, so that's another question done for this paper. And the next question is about conduction, convection, and radiation. I'm going to go through this as well to speed up the process. Okay, so this case, this is particularly badly answered by students who struggle to communicate in English clearly. So the mathematical bits, the students find very easy, but if English is not your first language and you're in a British system school, and you're still becoming accustomed to answering these questions in English, these are the most difficult kind of questions. And it's still, that physics is 50% maths and 50% communication in English. So you've got to be very good at knowing which terms to use. That's why going through these exams with me and by interpreting the mark scheme to see what they give marks for and what they won't give marks for is the best way to revise. Okay, so question 8. It says, in some countries, snow can fall and collect on the ground. Okay, diagram 1 shows that after the snow has fallen, the sky can be clear, leaving the snow directly exposed to the sun. Okay, so what does the sun do? The sun is giving out radiation. Yeah, and this radiation comes in like infrared, ultraviolet, and visible light. Okay, so what are they asking? They're saying, explain why the white snow. They're telling you snow is white. So the answer is to do with the color of snow. If the fact that it's white, yeah, the fact that it's white is what you should pay attention to. Now, white is a poor reflector, a good reflector of radiation. So we're talking about infrared, really, heat, yeah? So remember, heat is infrared. So that's the key terms you should be thinking about. So it says a white surface will reflect, so 1 mark for saying reflect, the sun's radiation or infrared. Because white is a poor absorber or good reflector of infrared. So the second bullet point is additional detail. 1 mark for realizing it's about radiation and reflection, and 1 mark for giving additional detail to show that you know enough about it. Okay? All right, so part A is about radiation and absorption and reflection. Part 2 then, it mentions the fact that there is a metal drain cover. Yeah? So underneath the snow, part of where it's fallen, there is a metal drain cover here, but not next to it on either side. So the fact that it's metal should give you a clue. If the snow lands on the metal, the snow takes a shorter time to melt. Well, the amount of radiation hasn't changed. Yeah? You're still getting the same amount of radiation coming from the sun, but explain why, it says, explain why the snow melts in a shorter time on the metal drain cover. So you've got to immediately say, okay, metal is a good conductor. Yeah? So the first thing you've got to say is that explain why the snow melts in a shorter time on the drain cover. Now, the drain or the metal is a good conductor. 1 mark. Okay, so the second part is about conduction. And the ground underneath, we're assuming it's warmer than the snow. That won't always be the case. So this is, I think, why it's a tricky question, this part. The ground underneath here is not frozen or is not as cold as the snow. We're assuming that. And I think it's not always good to assume that, but, you know, that's what you've got to do. So the metal will conduct or transfer energy to the snow from below. Yeah? The ground is warmer, so the heat will go from the ground, through the metal, and melt the snow from underneath. It's not that the metal drain cover, as some of my students were saying, has absorbed the sun's radiation. Yeah? How? It can't get through, the radiation can't get through the snow because it's bouncing back. Yeah? So it's nothing to do with the sun and the metal absorbing the energy of the sun. It's basically transferring heat from underneath through the metal because it's a good conductor. So that bit will conduct quicker than, say, from the side here and from the side here where there is just the normal ground. Okay? So part 2, I think, is slightly unfair in that we're assuming the ground is not frozen. Okay? So part C then says, explain why a convection current above the snow increases the time for the snow to melt? Well, convection current. So all you've got to do is, if you see that they're putting one part radiation, one part conduction, third part, they're telling you, explain how convection currents work. They want you to know. Well, any warmer air will rise above the snow. So the warmer, any bit of air that's warmer will rise up, and cold air will stay nearest to the snow because cold air is denser and it will sink. So you always have the cold air close to the snow. That means it stops the warm air from touching the snow. So this will reduce the amount of heat transfer from the warmer air, because the cold air takes the place of the warmer air. Okay, and that's how you can explain the convection. So conduction, convection, and radiation are some of the most difficult questions to make sure your language is used concisely and clearly and precisely. So the mark scheme for these 3 points above, yeah. So there's A is reflection. So these are the key terms. Any reference to absorption or reflection of infrared heat, and then the idea that white objects are poor absorbers or good reflectors, again of infrared, and then the 3 marks for the conduction. Yeah, drain cover is warmer than the snow, well, we're assuming it is. Idea that drain cover is a good conductor, yeah, and then that the fact that the energy transfers from the drain cover to the snow, okay? And then for the third part, I told you that warm air rises, gets you 1 mark. Colder air stays nearer to the snow as a result, and therefore the rate of heat transfer from air is reduced by the fact that cold air stays close to the snow, okay? So let's stop the video there. We've just done 3 more questions, 6, 7, and 8, and the question 9 is then going into pressure, it looks like. So thanks for watching. Don't forget, show your appreciation, attitude of gratitude, like each video you watch and find useful, share it with any friends, especially in other schools, and make sure you subscribe. Bye for now.